Moving on, let's look at the solutions in alternative form. Well, knowing these various relationships, we can rewrite the free response equation for an underdamped system as this. And this is what you may have seen before, okay? So notice the only change we've made is we've replaced minus gamma upon 2 with minus zeta omega naught, okay? Because that's the relationship we came up with. And so that's the form of the equation you may have seen before, okay? So zeta omega naught gives you the extent to which the thing is decaying, okay? And obviously omega d and alpha are the same, and a is the same. And we'll talk a little bit about how you apply initial conditions for this equation in a minute. Now for force damped equations, okay, if you remember we came up with an equation that had A and delta in, and A, instead of being defined by initial conditions, was defined by the characteristics of the system. Now we had an equation for A. It looks a little bit like this, but it didn't look quite like this. But one of the exercises in your notes will be to find this equation from the other equation in the one that we covered last week. But you can rewrite it in this form, okay, in terms of omega naughts and in terms of zeta, okay. And obviously, wherever you see an omega divided by omega naught, okay, you can substitute in R. And for phase angle delta, you can do the same thing. You can substitute in wherever we had a zeta, you can substitute in, wherever we have a gamma, we can substitute in the new form in terms of zeta. And again, down here, you can change that around, and you end up with this equation in terms of R. Now, last week, we also had this equation. If you remember, if we go back to that slide with the pictures on, this one here, the value for this amplitude, when you're at this frequency, was defined by Q times by the static amplitude. So here we've got a Q of about 5. Okay. Static, the amplitude ratio here is 1. You multiply that by Q, you get up to there. Okay. So increasing Q, you get a bigger peak. And obviously we came up with an equation that relates Q and damping ratio. And so you can basically replace Q with 1 upon 2 zeta. And you can see quite clearly that as this goes down, if zeta is small, then the amplitude will go up, and vice versa. So it's just taking the equations that we covered last week and putting them in alternative forms in terms of zeta and things like that. And again, we covered this briefly. The frequency that results in the maximum amplitude is defined there, 1 omega naught square root of 1 minus 2 zeta squared. Okay? And the amplitude at maximum frequency is f naught upon k times by this term. Now that's, like I said, this bit is the addition that we've got. The previous slide we had 1 upon 2 zeta. Okay? But obviously this bit here accounts for the fact that it's not actually at the natural frequency. It's slightly less than, depending on how much damping you've got.